Let's review more about the key concepts of numbers and operations that you need to know for the SAT. In this video, we will discuss about powers and roots, exponents, law of exponents, squares and square roots, the perfect squares, properties of square root radicals. Now let's start with exponents. An exponent tells you how many times a number or the base is a factor in the product. Let's say, for example, you're given 4 to the power of 5. So 4 to the power of 5, the 5 here is the exponent. So that means you multiply 4 to itself 5 times. So this is just equivalent to 4 times 4 times 4 times 4 times 4, which is equal to 1024. So 4 here is the base and 5 is the exponent. Now exponents can also be used with variables. You can substitute for the variables when values are provided. Say for example, b to the n. So b here, this one, represents a number that will be a factor to itself n times. So n is the exponent. Let's say if b equals 4 and n equals 3, then b to the n is just 4 cubed. And 4 cubed is 4 times 4 times 4. So you multiply 4 to itself 3 times. And this is just equal to 64. You have to take note that in solving exponents, you have to identify your base and the exponent. Let's say we're given this problem here. Which of the following is equivalent to 7 to the 8? So 7 raised to the power of 8. Now our base here is 7 and the exponent is 8. So that means 7 is multiplied to itself 8 times. Now let's take a look at the options here. So we have, okay, so it should be 8 times. So that means D fits for the answer to the problem. So the answer is letter D. And for laws of exponents, any base to the 0 power equals 1. Let's say, for example, we're given 12xy to the power of 0. This is just equal to 1. Also 80 to the 0, that one is equal to 1. Say 8,425, 8,425,328 to the power of 0, still equal to 1. And when multiplying identical bases, we keep the same base and add the exponents. Let's say we have b raised to the power of m times b raised to the power of n. So we have the same basis here, which is b. Then we just have to add the exponents. So this is equivalent to b to the power of m plus n. Let's say, for example, we're given 9 to the 5th times 9 to the 6th. Since the expression have the same basis, then we just copy the base, which is 9, and then we add the exponents, which are 5 and 6. So this would become 9 to the power of 5 plus 6 and 9 to the 11th. Let's say we're given this one, a to the squared times a cubed times a to the 5th. Since all of the terms have the same basis, which is a, we just copy the base a, and then we add up all of the exponents, 2 plus 3 plus 5, which is just equal to a to the 10. And when dividing identical bases, we keep the same base and subtract the exponents. Let's say we're given b to the m divided by b to the n. We can rewrite this as b to the m over b to the n. b to the m over b to the n. We copy the base if the terms have the same basis, and then we just subtract the exponents. Therefore, this would become b to the m minus n. Let's say we're given 6 to the 5th divided by 6 cubed, or we can write this as 6 to the 5th over 6 cubed. Since they have the same basis, then we copy the base 6 and then we subtract the exponents 5 minus 3. So this is just equivalent to 6 squared. How about this one? Let's say we're given 8 to the 9th over 8 to the 4th. They have the same basis, which is a. Then we just copy the base a and subtract the exponents 9 minus 4. Then this would become a to the 5th. And if an exponent appears outside of parentheses, we multiply any exponents inside the parentheses by the exponent outside the parentheses. Let's say we're given b to the m to the power of n. So this is the power of the power rule. Then we just multiply the exponents m and n here. Then this would become b to the m times n, or b to the m n. Say for example, we're given 4 cubed to the 8, and this would become 4 to the power of 3 times 8, and then 4 to the power of 3 times 8 is 24. What if we're given this j to the 4th times k squared to the power of 3? So we already have two terms here. What we're going to do here is we distribute the exponents, the outside exponent to the inside exponent. So this would become j to the 4th times 3. So we do it one by one, as well as for k squared times k squared, k to the 2 times 3. Then we simplify j to the 12 times k to the 6. Or we can just write this simply as j to the 12 k to the 6. Let's say we're given this problem here. Which of the following is equivalent to 6 to the power of 12? So let's take a look at the choices here. First one, letter A, is 6 to the 6. 6 to the 6 is just equal to 6 to the 36, because you will multiply 6 and 6 here. So that's not equivalent to 6 to 12. And then for choice B, 6 squared plus 6 to the 5th plus 6 to the 5th. This isn't the answer because exponents don't combine in addition problems. And then for C, all right, C here, they have the same basis, so we can just add up the exponents 6 to the 3 plus 2 plus 7, and this is just equal to 6 to the 12. So the correct answer here should be letter C. Let's take a look at letter D. Letter D is 18 to the 15 over 3 cubed. So in this case, we cannot directly apply the law of exponent division rule, which we just subtract the exponents because they don't have the same basis. So we have to rewrite 18 as a term with a base 3. As well as letter E. Okay, letter E is not the correct answer. They have the same basis here, 6, but then we have to subtract the exponents. So 4 minus 3 is equal to 1. So this would become 6 to the 1, which is not equal to 6 to the 12. So the best answer here is choice letter C. Now let's discuss squares and square roots. So the square of a number is the product of a number and itself. Say for example, the number 25. So the number 25 is the square of the number 5 because 5 times 5 is equal to 25. So we can write this as 5 squared, and this is just equal to 5 times 5. So the square of a number is represented by the number raised to a certain power. In this case, 5 is raised to a power of 2. If we're given a squared, then we can write this as a times a. Now for the square root of a number is one of the equal factors whose product is the square. Say for example, 5 from the previous example. 5 is the square root of the number 25. We can write this as the square root of 25 is, you can write 25 as 5 squared. Then the square root of 5 squared is equal to 5. And this square root symbol is called the radical. Okay, this is the radical, and the number inside is called the radicand. Let's say we solve for the square root of 36. The 36 can be written as 6 times 6 or 6 squared. Then the square root of 6 squared is just equal to 6. Since 36 is the square of 6. Let's solve this problem. Which of the following is equivalent to square root of 196? So what is 196? Is it a perfect square? So 196 can be written as 14 times 14 or 14 squared. And the square root of 14 squared is just equal to 14. Therefore, the square root of 196 is equal to 14. So the answer here is letter B. 196 here, together with 25 and 36, those are called perfect squares. So a whole number is a perfect square if its square root is also a whole number. But in other cases, the square root of some numbers might not be a whole number. Let's say, for example, we're given a square root of 8. This one, the square root of this is not a whole number. There is not a whole number that can be multiplied by itself equal to 8, because square root of 8 is to something, 2.828, and so on. We can write square root of 8 as 4 times 2, and 4 is a perfect square because we can write 4 as 2 squared times 2, and then we can put 2 outside of the radical, but we're left with 2 inside the radical, so it's not a perfect square. Take note of the perfect squares. 1 is a perfect square, 4, 9, 16, 25, 36, 49, and so on. These are examples of perfect squares. Now let's take a look at this problem. Which of the following is a perfect square? So let's take a look at the choices here. We have 72, 78, 80, 81, 88. So for 72, we get the square root of 72. It would give us the result that is approximately 8.485. And for square root of 78, this would be equal to 8.832. Then square root of 80, this would give us 8.944. Then square root of 81 is equal to 9. Square root of 88 is equal to approximately equal to 9.381. So among the choices here, only 81 is a perfect square because the result when you get the square root of 81 is a whole number. So A, B, C, and E are not the answers. Now let's talk about the properties of square root radicals. The product of the square roots of two numbers is the same as the square root of their product. Let's say we're given the square root of a times square root of b. So the product of the square roots of these two, a and b, is just the same as the square root of their product. So we can write this as the square root of a times b. Let's say we're given square root of 7 times square root of 3. Then we can write this as the square root of 7 times 3. And 7 times 3 is just equal to 21. So this is just equal to square root of 21. For the quotient of the square roots of two numbers is the square root of the quotient of the two numbers. Let's say we're given square root of a divided by square root of b. So we can write this as the square root of a over b, where b should not be equal to 0. Okay, for example, we're given square root of 24 over square root of 8. Then we can write this as the square root of 24 over 8. And 24 is divisible by 8. Then we can write this as the square root of 3. Now the next property, the square of a square root radical is the radicand. Say we're given the square root of n squared. A square root of n raised to the power of 2 is just equal to n. Say for example, we're given a square root of 4 squared. We can write this as the square root of 4 times the square root of 4, which is just equal to square root of 16. And this would give us an answer that is equal to 4, because square root of 16 equals 4. Or you can just simply get rid of the radical in the exponent 2 here. Then you get the answer that is equal to 4. Now, when adding or subtracting radicals with the same radicand, add or subtract only the coefficients. So, and then we keep the radicand the same. Say, for example, a to the square root of b plus c to the square root of b. So they have the same radicands. We just have to add up the coefficients of each of the terms. So we can write this as a plus c, then copy the radicand square root of b. Say for example, we're given 4 square root of 7 plus 6 square root of 7. Then we can write this as 4 plus 6 square root of 7, or 10 square root of 7. Now take note that you cannot combine radicals with different radicands using addition or subtraction. Say for example, square root of a plus square root of b. So you cannot combine them. This is not equal to square root of a plus b. As well as square root of 2 plus square root of 3 is not equal to square root of 5. Now to simplify a square root radical, we write the radicand as the product of two factors, with one number being the largest perfect square factor. Then write the radical over each factor and simplify. Say for example, we're given square root of 27. The square root of 27 can be written as the square root of 9 times 3. Because 27 is equivalent to 9 times 3. Then we can write this separately as square root of 9 times the square root of 3. Since 9 is a perfect square, we can write that as square root of 3 squared. So the square root of 3 squared is just equal to 3. Then this would become 3 times square root of 3, or simply 3 square root of 3. Therefore, square root of 27 is equal to 3 square root of 3. How about square root of 8? Square root of 8 is not a perfect square, but we can write square root of 8 as 4 times 2. Or we can write this separately as square root of 4 times square root of 2. Since 4 is a perfect square and can be written as 2 squared, and the square root of 2 squared is just equal to 2, then this would become 2 times square root of 2, or simply 2 square root of 2. Now let's take a look at the problem here. Which of the following is equivalent to 2 square root of 6? Let's take a look at each of the choices. So for choice A, this is 2 square root of 3 times square root of 3. So we can write this as 2 square root of 9. And this is not equal to square root of 3. So this is not the answer. How about choice B? Choice B can be written as square root of 24 can be written as square root of 4 times 6. And 4 is a perfect square, so we can write this as square root of 2 squared times square root of 6, or simply 2 square root of 6. So the answer should be letter B. The rest of the choices, we can, for letter C, 2 square root of 9 over square root of 3. So this is 2 square root of 9 is 3 over square root of 3. So this is 6 over square root of 3. And then we rationalize. This would become 6 square root of 3 over 3, or 2 square root of 3, which is not equal to 2 square root of 6. So letter C is not the answer. And then for letter D, we cannot combine radicals with different radicands using addition or subtraction. So we cannot, letter D is not equal to 2 square root of 6. But if you're going to solve this, this would become 2 times 2 plus 2 square root of 2, or 4 plus 2 square root of 2. And for letter E, square root of 72 can be written as 36 times 2. And 36 is a perfect square. So we can write this as square root of 36 times square root of 2. This would become 6 times square root of 2, or 6 square root of 2, which is not equal to 2 square root of 6. Therefore, the correct answer here is letter B, which is equivalent to 2 square root of 6. Now I will discuss more on numbers and operations in the next videos.